Hi class, we're back with lesson 5 part C, and we are still talking about personal finance. In fact, we're going to go back and reuse some data that we had in the prior lesson. And we're talking here, it says in an earlier activity we created the frequency tables for the 2013 gas mileage data. And the tables do help you to form a better understanding of the data, but an even more helpful thing sometimes is to have some type of a pictorial representation, which would be a graph typically. And so we're going to talk about how to make histograms. So we have the data from, hold on a second, let me get my pen going here. So we have the data that we had before from the other lesson. We have the ranges, 18 to 20 miles per gallon, 21 to 23 miles per gallon, and so on. And this was for the mini compacts for 2013. And then we had the frequency here, 3, 3, 14, 13, and so on. And if you remember, we did this in the prior lesson. So they have this kind of started here for us with the histogram, and it has the labels on it, but we're going to fill in all the details here. And before I actually continue drawing this graph or this histogram, I'm going to get the labels on here. So you notice it says to make sure you label it correctly. So I'm going to get a title on here, and I'm going to get the axes of the graph labeled. So at the top here I'm going to put just something real basic, but so that it makes sense. So this is the 2013 mini compacts. And down here we have the miles per gallon that they get. And over here, apologize, this is really hard to write sideways on this. We have the frequency. Try that again. Okay, so over here on the side we have the frequency. Forgive me, this is really hard to write sideways on. Okay, so that should be a little bit more vertical than it is, but hopefully we get the idea. So on this then we're going to finish with the numbering. We're going to go in the same pattern. When you make a graph, you need to make sure that the spacing is equal. So here, this is 15 to 18. We don't have a choice after that. This has to be 18 to 21. Once you decide that the spacing between these is 3 apart, then they all have to be 3 apart. So same thing here. Since they've started this at 2, we can't make this 5 or 10 or something like this. If this is 2, then the next one has to be 4. The only thing that they did do here is they did kind of split the graph right here, and I'm going to actually put a little split mark here just to kind of show that, hey, the graph was split there. So then this becomes 4 and 6 and 8, 9, whoops, not 9, 8, 10, 12, 14, 16, and 18. So this is how many times that that range of miles per gallon occurs, and then this is the range of miles per gallon. So you notice the first one, 18 to 21, matches up with their 18 to 21. And you notice the bar here, it's supposed to come up to 3. It looks like it's a little high. It should have maybe been more about, let me change it to a different color here. It should have been, it looks to me like it should have been more about right here. So I'm not sure why they have it a little bit too high, but it should have been right in between the 2 and the 3. So now if we continue like that, then our next one is going to be the 21 to 23, and it's also going to be 3 high. So I'll make that one where I think it should have been. So now with a histogram, we typically will put these bars. They don't have to be filled in, but a lot of times they are filled in. So if we fill this in, there's our first bar for 21 to 24, or our second bar, first one we did, for 21 to 24 miles per gallon. Now the next set is from 24 to 26, and it's for, there are 14 vehicles that were in that range. So we want to take this all the way up to 14. Looks like it's going to be up to here and over. If you were doing this on your own, it might be nice to pull out a ruler, but also it's just easier to draw things when you can actually have it on the paper. But that bar should be straight on each side. So we fill that in. Go a little bigger, but not so crazy big. And then our next one is going to be 27 to 29, and that's going to be 13. So a little bit lower than that other one. And one thing I wanted to point out is the labeling for the numbers here is not exactly the same as the labeling for the numbers in the table. Typically with a histogram, we'll take the values and we have to have a break here. So like here, this goes from 27 to 29, and then this one goes from 30 to 32. But on the graph, we don't want to put a 29 and a 30. So what they've done here in this graph, or in this histogram, and what we can do it the opposite way, but what they've done here is they've decided to do all the lower bounds. You can do the upper bounds, but it's more typical to do the lower bounds. So they've only done the 18, 21, 24, and so on. So when I look in here, this is not actually 18 to 21. This is 18 up to but not including 21. And then this would be 21 up to but not including 24. So what we call that is we say the lower, or the boundary numbers go into the upper bin. So this boundary here of 21 goes into the next bin, not into the lower bin. So the 24 goes into the next bin. Anything that was 27 would go into this bin. So all of these end up being the lower numbers here, 18, 21, 24. Okay, so we've got the 13 now. Next we'll do the 2, which would be even lower than these ones that we had over here. Okay, so we've got a bar of 2. And then we've got 33 to 35 is at 13 again, so it should match up with this one up here. Ooh, that got crazy. Okay, so there we go. And then our last one is at 3. I'll put that in first. So here's our last bar. And again, you don't have to, if you were doing these by hand, you don't have to fill those bars in. Actually, you guys aren't going to be required to do many of these on your own. They're going to just be given to you for the most part, and you're going to have to be able to read them. You may have to draw an occasional one, but mostly it's just a matter of being able to read them. Okay, so now if we look at this histogram, we have a good pictorial representation of how the data looks. So we have 2013 mini compacts. We have the miles per gallon. We have the frequency, and we can see that it's real low here. We have this one little odd range here that only has 2 in it, but then we have this most of the values in these 3 ranges. And if we wanted to say, you know, most of the values are from 24 to 36, there's only a few values that are here and here. So it gives us a nice, real quick visual when we're looking at, even more so than the table does. So now it says, write a sentence explaining what the histogram illustrates. Does it help you gain a better understanding? So what it illustrates is the heights of the bars are the frequencies for the ranges. For those ranges of miles per gallon for the 2013 mini compacts. And does it help you see it? Yes. Your brain would much rather see this type of a representation than this type of a representation. Your brain can typically process this a lot faster. There's a reason we have the phrase, a picture is worth 1,000 words. A graph is a type of picture. And so our brain typically processes a graph a lot faster than it does a table. With the table, we have to look and kind of analyze the numbers, whereas here we can pick up these, you know, what bar is higher and things like that a lot better, and we can pick up what the graph is about a lot quicker. So the next thing that the lesson asks us to do is to create another histogram using the relative frequencies from the frequency table. If you recall from the last lesson, we had another column here that was titled relative frequency. So let me fill that in. And I'm going to I'll start to fill it in and then I'll kind of pause and do the rest of it. So we had a column here that was called relative frequency. And then we took these numbers, and to get this number, we did 3 out of the total, and the total was out of 51. And so we took 3 and we divided it by 51, and that got us the relative frequency. And then we put it as a percentage. So this came out to be 0.0588, and so we rounded it to 0.059. Or 5.9%. And then we did the same thing. Since this is 3 again, this would also be 5.9%. 14 out of 51 comes out to be 27.5% if you round it correctly. Okay, so now I've filled the rest of these in. And we're going to use this for the graph rather than the frequency numbers. We're going to use these relative frequency numbers. So I cleared the graph over here and we'll redo it. I'm just going to do it in a different color, so just realize it's a different graph than what we were doing before. And we need this numbered a little differently. So before we needed to get up as high as 14 because that was the biggest number. Now we need to get up as high as 27.5. So I'm going to just kind of cross out what they have here since they have a 2 here. Since I need to get to nearly 30, I think I'm going to go see if I can go by 5s. 5, 10, 15, 20, 25, 30. I could do that. I could probably even, I can't go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18. That doesn't get me nearly as far. So I think I'm going to have to go by 5s here. So I'm going to change this 2 to a 5, and then this is 10. And this is 15 and 20, 25, and 30. We won't need to go any higher than that because our highest number is only 27.5. We could have gone by 4s or something like that, but sometimes that bothers people when we go by something that we're not really entirely used to. So now here I'm going to write again frequency . And actually what I should be writing is relative frequency. Okay, so that's supposed to say rel frequency. So I fixed this so that it looks just a little bit better. This is supposed to say relative frequency in percentage. So this would be 5%, 10%, 15%. So if we fix this, it's actually not too far off. Our relative frequency for our first one is supposed to be 5.9%. So it's a little bit high. It should be more like about here. And I'll just cover this up. So ignore the blue part. Only look at the green part here. So this bar should be about there. At about a little bit, at about 6%, close to 6%. Then we have another 5.9% for the next group. And then we have 27.5, which would be, again, almost to 30, but not quite. And then our next one will be at only 25.5. Okay, so I'm trying to keep you from having to watch me do all this coloring here. The next one's at 25.5, so it'll be a little bit less than that. And then our next one would be at 3.9, which is lower than our first two were. And then we're at 13 again, so we're up to here again, not 13, but 25.5%. And then we're at 5.9% again. So that's the same as the first two bars. It's a little bit higher than this one, but it should be the same as these. And then I'll go in and color those in. And then lastly, I should have done this probably before I started, but let's not forget that we should have a title and labels here. So up here, I'm going to title this 2013 Mini Compacts again. And down here, I'm going to label this miles per gallon. So what does this show differently than we had before? Well, you'll notice the bars are very similar. I mean, the bars kind of go in the same pattern. We have the two lower ones, and we have the three that are the highest. We have this one in the middle that's kind of weird because it drops down in between these big ones. But it still has the same overall shape, but it gives the percentages rather than the actual number. So we know that this is 6%, almost 6%, rather than that it's 3 cars. So just gives us a little bit different data, even though the shape is a little bit different, or is the same as we had before. So now our fourth question on our lesson is to create a third histogram using the frequency table for the same data, but with the bins of size 10 instead of size 3. And again, we did this in the last lesson. We did the range from 15 to 24, 25 to 34, and so on. And that gave us frequencies of 11, 32, and 8. So if we took this data and we made a histogram from it, we have miles per gallon on the bottom. Again, I put on mine, I put MPG, but they wrote it out. Here we have frequency. Oh, and look, they did theirs horizontally. I guess I could have done that, and then I wouldn't have had to try to write sideways. And then they have a 2013 gas-powered Mini Compacts as their title. So you'll notice, because we only have 3 bins here, we only have 3 bars. We don't get the same type of a shape as we had before. We see that it's low here, high in the middle, low on this end, but we don't get quite as much information. So it says to write a few sentences that compare and contrast the 3 histograms. So some of the things that they mention in the answers. Oh, and I kind of cheated, by the way. I didn't take the time to actually draw this out. So you can draw it in your notes if you want. But I kind of cheated and went to the answers and got that. It says some of the things that you might notice is that you might feel that when the bin is size 3, which was the first one we did, that the data are spread out, maybe making it harder to see the overall shape. Especially because we have that one bin that went from 30 to 32 that kind of broke up the idea of where most of the data are, because it went from 14 to 13 to 2 and then back up. But on the other hand, when the bin size is 10, the data is so clumped together that we sort of lose some of the detail. So, you know, which one is better? It kind of probably depends on what you're using the data for. I tend to prefer the one that's a little bit more spread out. I think this is too clumped together and loses any of the details. And then, of course, the second one that we did gives it in percentages instead of frequencies. So it gives the same shape, but just a different way to represent the information. So now we're going to finish up lesson 5 with discussing shapes of distributions. And the first distribution that we're going to look at here is on the resting heart rates of 100 adults. So how many beats per minute the heart rate for these adults are. It says that this is called a dot plot, by the way. This is a little unusual that it has these triangle shapes. Usually a dot plot literally has dots instead of these little triangles. But each of these little marks is supposed to represent one person. So for instance, it's a little hard to tell because these are kind of spread out, but this looks like it would be 60. Then, of course, this would be 61, 62. So this would mean one person has a heart rate of 60, one person has a heart rate of 61, one person has a heart rate of 62. If we go over here right above 80, it looks like there's about 1, 2, 3, 4, 5, 6, 7 people who have a heart rate of 80. And we place that right above the 80 mark. If we go back over this way, this looks like it's right above 100. So it looks like there's 2 people who had a heart rate of 100. This looks like it would maybe be 101, 2, 3, 4, 5, maybe 105. There was one person that had that, and then so on. So every one of these little marks is one of the 100 people. I'm sorry. It actually doesn't say that there's 100 people. I'm not sure how many there are. We'd have to count all the dots. So how would you describe the shape of this graph? Well, just in general, I mean, we can see that the shape starts with relatively few number of people in this area, then it peaks, and then it comes back down. So if we wanted to talk about a shape, we might say that the shape is like a hill, or it's low on the ends and peaks in the middle, kind of like a mountain, or most people will say it's like a hill or a mountain. But the biggest thing is that it peaks in the middle and then it gradually kind of goes down on each end, and it's fairly symmetric, meaning that it's kind of shaped the same on each side. And what does the graph tell you about heart rates? Well, there's several things we can notice about that. First of all, it looks like the average or the middle of these is around 80. So it looks like about, it may be just a little higher than 80, maybe 81, but it looks like about, this cuts the graph or the people in the graph about 50-50 at around 80. So a typical heart rate is around 80 if we wanted to give one number. If we wanted to give kind of a range of numbers, we could say that the heart rate went from typically around 70 maybe to around maybe 100. We could even say more like maybe 95. And that shows that it's not exactly symmetric, because there are a few more over here than there are on this side. But it seems like a typical heart rate is around from maybe 65 or 70 up to about 95 or 100. And that's where almost everyone is. Also, we can see that there's very few people that have this low heart rate below 50. There's only one person that's below 50, actually. And there's only 2 people that are above 105. They look like they're maybe right at 110. So there's only a couple people that are at 110. So we can pick out a lot of detail out of this graph relatively quickly. Again, that picture, our brain really, really likes that form of representing information. So now we have another dot plot, and it says to read carefully to determine what the symbol means. In most dot plots, this is actually kind of uncommon the way that they did this, but I'm going to try to explain it as best as I can. Each of these X's, instead of representing one person or one family, this is the U.S. Census Bureau report for 2011 household income. So these marks, each of these marks is 1,000,000 households. So these 4 X's that are stacked up here, that's 4 million households that are in that category. Now, that says it's at 0 if you look here, but then down here it says that the bin size is actually 5,000. So 50,000 actually means 50,000 to 54,000. So this first row right here, or I'm sorry, this first column, wouldn't be necessarily 0, but it would be 0 to 4,000. And then they've rounded these to the nearest $1,000. So 4,000. If a family made $4,320, for instance, they would still be labeled at 0. So they're not going to make it up to the 5,000 mark until they make over $4,500. So this would be 0 to 4,499. This would be 4,500 up to 10,000 or 9,949, and so on. So these are each in that form. So let me go up to one that's a little bit further up. So these, again, it's 4 million. There's several that are 4 million. These 4 million families made from anything that would round to 50,000. So 49,500 up to 54,499. And that's how that goes on each of these. I know it's kind of confusing. I even have to think really hard to follow along with what it's doing. But what they want us to do is pick one column and write a sentence about its meaning. So we're going to pick one of these columns. Let's pick that one that I was just looking at. So this column right here, I'll circle it, is what we're going to talk about. And we can pick any one we wanted, but we'll do this one. So there are, if we write this out, that would mean that there are approximately 4 million households with income from, and again, it's anything that would round to 50,000 up to, but not including anything that would be 55,000. So it would be 49,500 to 54,499. Hopefully that's what I said before when I said that. So 49,500 would round up to 50,000, and then all the way up to 54,499, because that wouldn't quite round up to 55,000, because this next column would be the ones that started at 55,000. So 54,499. And that's what that column represents. Let's do one more just to kind of keep it, to get another idea. So for this one, it says to only do one, but we'll do two. So there are approximately 2 million with income from 99,500, because that would round to 100,000, to 104,499. So we're going on either side. So a little bit below 100,000 and then up to, but not including things that would round up to 105,000. Let's do one that's sort of in the middle because they're a little bit more complicated. So let's do one that's, say, let's do this one. So we have to figure out where it starts at. There's 1, 2, 3, 4, 5. So there's about 5 million with income from, what would this be? So this is 0, 5, 10, 15, 20. So this would be starting at 25,000. So from 24,500, because that would round up to 25,000, to 25,000, be 29,499, because 29,500 would round up to 30,000. So hopefully that makes a little bit sense. What does the overall shape of this dot plot tell you about the household incomes? Well, you can see there's a lot more households that are on this end of the scale than this end of the scale. So we have a large majority of people that are making definitely under 100,000. We could probably even say under a good majority, about half of them at least, are making under 50,000. Yeah, that definitely looks like more than half of the X's on this graph. You have very few people that are making up here, and in fact, it says here that there's actually only 5 million households that are past 200,000 that they didn't put marks up here because they were so spread out we couldn't even cluster them into groups of 1 million. And so there's an additional 5 million households that are from 200,000 up that aren't even on here. But still, even at that, we still have a vast majority of households are from this $100,000 on down. In fact, like I said, we could probably even say from here down, $50,000 or $60,000 or less. How would you describe the shape? Well, it's not like that other one we had where it was low on both sides and was kind of like a mountain. It's almost more like a slide. We actually call this skewed right because this has this long tail to the right. And if we were to, a lot of times when they mention income, they don't talk about the average income per se. They don't say the mean income where you add up all the income and then divide by how many families there are. What they'll use is they'll use median, which is the middle of where the data is, because these values up there skew the average, that mean, up and make it look higher. So the Bill Gates of the world and the Mark Zuckerberg, is that the name of the guy who did Facebook? These people that are up here that have so much of a high income, they would skew the average, professional athletes and things like that would skew the average and make it look like it was higher than what a typical family has. And so what they'll typically do is they'll discuss the median, which is cutting the data, half of the families above and half of the families below, which would be more, again, in probably about this area. So the median income is probably more like around 50,000. So the shape of this is, I would say, skewed right. I'm going to go ahead and write that down. Skewed right, which means it looks like it slides to the right, or that it has a tail. Think of this as kind of an animal, and this is its tail hanging off here. Has a tail to the right. We call it skewed right. And that means the average would get pulled upward. So now our next one that we're going to look at the shape, it says we're going to look at this stem and leaf plot that we had from Lesson 5 Part A. How would we describe the distribution of this? Well, here again we had very heavy in the 20s. If you kind of picture this sideways, it's almost like a sideways bar graph, and the numbers are making your bars. So this is, goes out, what is that, 1, 2, 3, 4, 5, 6, goes up to, 8 high, whereas this is much, much longer, and so on. So I would say, again, that this sort of has like a peak, and then it comes back down. It's not completely symmetric, because this bar is shorter than this bar, and this bar is longer than this bar. I'm calling them bars, but how long the data set is. And so it's somewhat symmetric, but not exactly. but it does peak in the middle in the 20s. So how would you describe it? That's what they're looking for when they're asking for those descriptions. And then this isn't in your notes. This is the nice version of the histogram that we made in 5C. And it says, how would you describe the shape of this frequency histogram? Well, this is very unusual. This one is what we would call multimodal, because we have these three really high bars, and you can't really say, well, there was the most data in this one certain range. So because these three bars are all almost the same height, we would probably call this multimodal or trimodal. Also, it's not symmetric because it goes, it has these two, then it goes up, then it comes back down, then it goes up again. So it has kind of this gap in the middle, kind of this valley in the middle of these high spots. And so this would be very non-uniform, hard to describe because of the way that it jumps up and down. So kind of irregular, and several bars that are, or ranges that are the highest. And when I say modal is like most often. So these three bars have the most number of cars in them, but there were three that were very similar. A lot of data is what we would call just unimodal, like this. There's the most cars are in the second, or in the 20s, in that second category in the 20s. Whereas here we had three different categories that were pretty much pretty close to each other. And the last thing that we're going to discuss for Unit 5 is this graph with the fuel economy for 2013 diesel vehicles. We haven't looked at this data before. We had the mini compacts, and then we had, I believe it was all 2013 Chevy vehicles is the other one that we looked at in a table form. But this is the diesel vehicles. So it says, look at the relative frequency histogram, and this is a relative frequency histogram, so it gives these in percentages rather than in actual numbers. How would you describe the shape of this histogram? Well, this one kind of goes backwards of what we had before. Remember, the first one we looked at in this unit was more like this. This is sometimes called a normal curve, or a somewhat normal curve, or a bell curve, because it looks kind of like a bell. This often will be called a reverse bell. And it's actually not quite a reverse bell because this is so high. A true reverse bell would be more symmetric on the two sides, so it would go more like this. Since this one comes up higher, on the right, it's not truly a reverse bell, but it's close to a reverse bell. But it's definitely, instead of having a peak in the middle, instead of being like a mountain, it's more like, the whole thing is a valley. So what might explain the shape of the fuel economy for those 2013 diesel vehicles? Well, if you think about, you may not be a big car person, but if you think about the different types of diesel vehicles you have, there's small cars that are diesel vehicles, such as Volkswagens, and then there's big vehicles that are diesel, such as big trucks, or even dualies, the trucks that have two tires on the back. And so as you look at this, these are likely some of those small cars like the Volkswagens, and these over here are probably the trucks. The Volkswagens getting good gas mileage diesel vehicles, and the trucks getting low gas mileage diesel vehicles. And you don't have a lot in between. They're usually kind of a small car that are built for that good gas mileage, or they're a truck of some sort that's built for hauling capacity and things like that. So that's probably the biggest reason that we have this, where we have a lot here and a lot here, and then it sort of dips in the middle. So that's the end of Unit 5, and we'll pick back up with Unit 6 in the next video.